Hey, welcome back. Good to see you all again. Thanks for joining the channel, and Happy New Year. This is first video for 2025. Took a little break. I needed to recharge, get stuff done. I got stuff going on in the background, all kinds of things. So yeah, I've been really busy since December. End of December when I last posted a video. I took a little break and kind of felt good to get away from the bench and do some other things. And I think I might do that a little more often. Got to take care of myself. But first up for the year is this monster ROTEL RX-1203. This is another one of these monster receivers. It does not fit on the bench very good. It's hanging over by about 5 inches here. Yeah, this is I got two ROTELs in the queue. This is the one I'm doing first. This is the 1203. I have a RA-1412, I believe. It's an integrated amplifier. Kind of the same power, but a little smaller size, and it's a beast too. So that's going to be coming up. So I want to get these done. These have been sitting here since October of last year, and the person that brought them to me, he's kind of a ROTEL collector. I did the RX-1604, I think it was 1602 last year or year before for him, and he had been pleased with that. So I'm going to do these other two for him, get these out of the way because they've been sitting here a while. Now I kind of cheated on this one. I had the lid off and I've been doing a lot of stuff here. Okay, before I even turn the camera on, one of the things I've been doing is taking some performance measurements of what's going on. And to tell you the truth, there's a lot of stuff wrong with this receiver. The main issue is dirty controls, dirty pots. You'd be listening to it and a channel would drop out, and then you'd have to fiddle with the knobs to try and get it back. Sometimes it would come back, sometimes it wouldn't. A lot of stuff there. So some of the measurements I did is frequency response on both channels, and that was very telling in itself because the left channel has quite a poor frequency response when compared to the right. So that alone is a problem, and so we don't have both amplifiers working in unison and working together. So we got one doing different stuff. That's not good. Plus also distortion measurements at 1 watt. One channel was considerably lower than the other, so I assume there's a problem in the left channel that we're going to have to address. The right channel seems okay, it's behaving. It was really difficult to get measurements on the right channel, especially when I was doing the 50 watt tests. I would get volume dropouts on the right channel. I think it's got like a dirty or bad relay in it. I don't know. Twitchy noises on both left and right channels, so I think either it's dirty switches or bad transistors or something to that effect, and then all the switches. Okay, so dirty function switch, dirty volume pot. The volume pot has a weird thing where when I turn it up I can get power, and then when I hit a certain part of the range here the volume drops, and it's consistent over and over again as I do this. So there's something wrong with this volume control. I don't know what it is yet. I'm going to have to get in there and have a look. Another problem this thing has is the power switch. So let's plug it in. Power switch does not work. It is locked on. I think the contacts are welded. Okay, so that will have to be addressed. We have no power switch. Working power switch. If I beat it up, it might come back. I don't think so. We got a couple lamps out. It's not a big deal. A tone on here, and you can actually hear the distortion. See? Hear that? That's, you know, things need work. Definitely need work. Can't listen to music when you have stuff like that going on. Okay. Now, tuners. AM tuner. I never checked out the AM tuner yet. AM tuner seems to be working.
These magazines. A lot of talk about like toxic relationships these days. Toxic people.
Yeah.
So what I'd like...
Toxic people. We all know about that. Okay. So AM's working good. The meter's working. FM is a different story. It's deaf. Let me hang on a second. I'll connect up an antenna. Okay. I got an antenna hooked up. Now it picks up stations. It's very deaf. The meter does not deflect at all. Picking up stereo is a challenge. So it's so weak. There's no stereo. So definitely has a problem with reception. Let's go to the strong stations. Okay, we're getting stereo and it's coming in clear, but we have no meter deflection here, so there's something wrong there.
Mix 1079.
The meter deflection is pretty pathetic. It comes up a little bit. So that's pretty much it in a nutshell. So what am I going to do here? Let's have a look. Okay, I can't get everything in frame here. This thing's so big. So there's a lot happening back here. There's a massive transformer. It's about the size of my head. And it supplies two caps. These are 63 volt at 22,000 microfarad. I measured these caps. One is down to about 17,000, the other one down to about 15. So I'm going to look for replacements of these. Problem is, just looked on DigiKey this morning, and the replacement cap for this, same voltage, same size, is, oh, you don't want to know, $85 a piece, Canadian. That's where we're getting ripped off here. So those will have to be replaced. It's going to be expensive. We've got big massive heat sink here for the power amplifiers. We have 4 output devices per amplifier. So we got tandem outputs, I believe. Yeah. Some mains fusing here. This is the mains fuse, and this is the fuse for the lamps. So I don't know why they put them on the same board here. I don't like this because it's so close to each other, and I would like to see some separation between these. I might take this fuse off and do something different with this smaller fuse and just leave this one alone. It actually should have a cover too, because it's exposed mains wiring here. So that's fine. All along the bottom we have this huge tone board which handles all the switching, tone controls, volume controls, preamplifier, all that business. Yeah. So that's all going to have to be certain. The switches are all on here, so that's all going to have to come out. All those switches are going to have to be taken apart and cleaned because they are terrible. Right here we have a stand-up board, and this is, I believe, is the Phono amplifier. It's half shielded. Now, interestingly enough, I did measure noise floors on all the inputs, and on the Phono, I was getting 20 dB more noise on one channel, the left channel, than the right. So I might have a problem with one of the amplifiers, or the left channel amplifier here. It's quite noisy. So we have to address that as well. Down below here looks like we have a tuner and multiplex board. Okay. Using a couple chips here, UPC 1021, I think that's the AM chip, and then HA1137, and then what are they doing for IF, FMIF? Not really sure. Here's the main tuning head block. It's got the capacitor, and there's probably some circuitry inside here. This could be IF in here, I don't know. And then along the back, or actually right in the middle, they have a board. I think it does a couple of different things. This is power supply rectifier is on here. There's a relay, which I assume is the protect relay. I'm not sure. I'm looking for speaker relays. I'm not seeing them unless they're under the deck. But this all looks like power supply and protection circuits. Okay, everything seems functioning well with that. and then we have, of course, our other amplifier on the other side here. Not the best layout. They could have made it more compact, and they could have scaled down the case size of this thing. It doesn't need to be so huge, but when it sits on your shelf, it looks pretty impressive, I'll tell you. Okay, so let's have a look underneath. Alright, so I have to back the camera up so you can get this all in frame. So this is the bottom plate removed. It's got this huge board here. This is our tone controls and hinges, filters. What is this one? Balance, more switching, loudness control. Here's a volume pot, and I'm already looking here. I can see cracks on all the solder joints here on the volume pot. So that's part of our problem. You got tape monitor switches up here, and then input selection up here, mute. So this whole board has to come out and get serviced. It's the bottom of the FM tuner multiplex board, and bottom of the amplifiers. Really not much going on underneath. Amplifiers will come out as a module, and we'll service those independently. I have to remove the front plate and get this board out, which shouldn't be too hard. It looks pretty easy. It should just come out like this, and we can get all the switching service done on all the switches and pots, and that should be fairly easy. The power switch is down here. It's got access. I can remove that and service that. I don't know, I didn't point out earlier, this there's really nothing on the back here. We have inputs for our antenna inputs, and we have a bar antenna for the AM, and we also have 3 courtesy outlets and a plate that covers nothing. There's nothing under here. This is the voltage plate. So on the left side of the unit you have your 2 speaker outputs right here and here, A and B, and then this is all blank here. On the right side, you have all your inputs. You have your Phono inputs, 1 and 2, auxiliary. We have a DIN connector for Phono, and we have a switch for selecting between high and low Phono input. Now, I guess this would probably be used for, no, I'm not going to say because I don't know. Okay, and then you have tape monitor 1, tape monitor 2. One of them has a DIN connector, FM detector output. We have preamp out, main amplifier in, and then we have a switch to unite or separate those connections. So that's all on the one side. On the right side, all your inputs, left side your outputs. So I'll get started recapping. I'll probably work on tone board, phono equalizer, tuner. I'll get all this done. I want to start with all the switches and whatnot. So I'll pull this board first, start with that, get these caps on order, get these replaced, and then we'll work our way through. I really don't have an order of doing this. I just do it whatever is on a whim. It's all going to be done, so I just do start somewhere and continue till I'm finished. This board here will need all new caps. All these Elna caps, some of these Elna caps are probably mostly good, but you never know with caps of this age. You might find dead ones. So I'm just going to blanket replace everything. I know people don't like that, but that's what I do. And in the end, when you're done, it's a better product, especially when you have one channel not working good with the other channel, and that could be down to bad caps in one channel. And so we're going to go through do blanket recap. Also, I see carbon comp resistors scattered throughout, so I'll be targeting those as well, and they'll be coming out. On the amplifier boards, I see lots of carbon comps as well, so those will have to be scrutinized and replaced. So I'm going to get busy doing that stuff, and I'll bring you back in when I got more to talk about. Okay, I just got to start on it. I got the tone board out. I had to remove, actually here I'll show you, I had to remove the screws from the side, lift it up about an inch or so, just because this lip here would not clear underneath, so I just had to lift it up, put a screw back in to hold it, and then once I got this side lifted, I could finagle this out, and actually had to pull the front back a bit, back a bit, But it's out. And now what I'm doing, I'm just desoldering all the switches and pots. I'm going to remove all the switches and pots. And then recap. There's only about 15 caps on this to recap. Quite a few tantalums. I don't really target tantalums because they don't pose a problem. Unless they do pose a problem. Failure mode of tantalums is direct short. And rarely do I ever see a tantalum capacitor fail. They don't change value, they're stable over time, so I leave them alone. So I got halfway done with the switches. I got to remove all the solder. They use a solder sucker. That's the quickest way. Just go through and solder suck all the joints. And if any are stubborn, I go follow up with solder braid, and then out it comes. Switch here is quite involved. It's going to take me a while to get this switch out and cleaned and put back in. But it's all necessary because all the switches were bad and flaky. Also removed both power amplifiers. See, they're missing here. There's a big empty void here now. And set them aside. I'm going to deal with them probably last. But for right now, this is going pretty good. And considering I just started this morning, it's already ripped apart to the point where I can get caps. If I can get all the caps today, this isn't going to be a speed resto, but I'm just saying it's going really well. So I'll keep plugging away. I just want to give you an update. Another thing I noticed is somebody repaired these struts. These struts are usually made of plastic, and somebody put aluminum bars in and repaired those. So that's good. That saves me a job. Very good. And then it's a lot of cleaning. This thing's quite dirty. Inside and out it's quite dirty, so it's going to take a lot of cleaning. So that's also on the list. Okay, these switches, they're coming out. They're all covered in some oily film. You can see the oily film on them. But somebody's definitely sprayed these. Spraying's good for the short term, but it doesn't fix anything. The problem is oxidation. And you can't just spray something in and hope oxidation goes away, because it won't. It eventually comes back. So I've lost faith in these sprays that go in and spray controls, and they work for a while, but then eventually it's going to just come back. So I'm just going to have it open up here quick and have a look inside, and I want to see how bad they are. So okay, actually it's not bad at all. I've seen a lot worse. But I'm still going to clean these up. And they got some kind of oily film everywhere. You can see the oil. Clean this all up. The old grease is kind of turning brown. And we'll get these back in shape. I'll polish this. Take these off. I'll polish the silver. Clean up the oils and grease. And I'll treat with deoxit after I polish and clean, and we'll re-lubricate all this, put it all back together, and then we'll have like a brand new switch. Okay, just going through the Phono board right now and replacing caps. This is pretty basic stuff. I've got six electrolytics. One, 2, 3, 4, 5, 6. And now here we have, this is something that irks me, is when manufacturers do this. They have two tantalum capacitors back to back to form a bipolar capacitor, and these are 4.7 at 25 volts each, back to back. They have their negatives tied together, and what I do is I'm going to take them out and replace them with a single bipolar audio grade cap, 3.3 microfarad, 50 volts. That's sufficient, and that'll eliminate these two. Now, I was just looking at this before I turned the camera on, and I was shocked by something. Typically these tantalums don't fail. Let's pull some of these out and have a look. Their typical failure mode is short circuit, and that becomes a problem when you use them in a circuit that has reverse polarity or over voltage or over temperature. Okay, so this one here is 4.7 at 25 volts. I don't know if you can read that. It's printed there, the positive. Tantalums are marked different than electrolytics. They have their positive marked instead of their negative. So this one here measures 4.9 microfarad, 3.9 or 3.9 ohms ESR. So that's a good cap. Let's try this one. If I can get it out. Same value. Okay, positive. I'm not showing the meter here because I'm too lazy to set up a second camera. Okay, this one says, this one says 5.8 microfarad at 123 ohms ESR. So this one's failed. And typically you don't see them fail like that hard. Instead of 4.7, it's 5.7, and it's got 125 ohms ESR. That's wild. Here's two that I pulled out here before I turn the camera on. This one's 5.1 ohms, 68 ohms ESR. So that one's failed as well. Interesting. Maybe we got to start checking tantalums in circuit because this doesn't look very good. Okay, this one's 4.8 microfarad, 5.9 ohms ESR, which is okay. But these two failed. These two are okay. I wonder if because these maybe have seen reverse polarity on them. I don't know. Anyways, doesn't matter. I'm going to rip them all out. And I'm going to replace them with these. These are Muse Nichicon Muse bipolar capacitor, 3.3 microfarad, 50 volts. So it doesn't matter which way you put them in. Let me just get these holes cleaned out. It's interesting that I've never seen tantalum fail like that. Maybe I got to start checking more of them because obviously there's a problem here. I usually just leave them alone. So I'll put a single 3.3 microfarad in. Now these capacitors are in the signal path. These two transistors here and here, these are the output transistors, kind of like an output pair. And it's a complementary. This is a A921 and a C1980. Works like a little mini power amplifier, and it provides a signal through this capacitor out to the rest of the receiver. So I'm just going to put these in, and basically they're just there for blocking, DC blocking and coupling. Okay. And this, I'll clean this up, block those holes off, and then we're done. No, I'm not done. I'm going to check these other two, and if these have failed as well, I'll replace them. But looks like I'm going to have to start checking all tantalums from now on. Alright, while I got it apart, let's see if we can do anything for this power switch. It is stuck in the on position. It's not really clicking properly. Let's open it up. Really did some searching for toggle switches like this, power toggle switches, and you can't buy them. They don't sell them anymore. I don't know if it was what is with that, but we're going to open this one up. I'm guessing it's just welded contacts, and if we can just get things flowing again, we can probably still use it. Alright. So what do we got here? We have we got my tweezers. This thing is supposed to be here, and there's a spring on those two buttons. Okay, that part's fine. Now, right here. Here's where we got troubles. Got grease in here, and they are welded The beauty about this switch is you can actually flip it upside down and reverse the contacts. You put these white and yellow wires on this side, flip this upside down, connect it all back together, because it is kind of, see if I can pull these out. Yeah, that's welded. And that contact is, ooh, that contact's pretty much gone. Let's try this one. Same thing. Looks like somebody sprayed something in here. That's probably what caused it to die. But we got 2 burned contacts on this side, 2 burned buttons on this side. This one's brand new, this one's brand new, never been used. This one's brand new, brand new. You see what I'm getting at? So if we can just reassemble this back together and put it to use again, and we can actually, we don't even have to, yeah, we should. We'll move these 2 wires over to here, and then we'll just reassemble the switch back together, and away we go. So let me get my iron going, and I'll get these wires moved over. This is not ideal the way they did it. They have mains power switched twice. I don't know if you can see this. This side is switching the mains, and this side is switching the mains. So instead, what they're doing is they're using 2 switches in series, and that doubles the chances of a failure, and it halves the chance of redundancy. If you get rid of this contact, join these 2 wires together, solder them together, and then if you take this contact and join them together, this and join them together, and then run your switch through these 2, you're actually doubling its life because you're reducing the chance of failure by half. I don't know if that makes sense to you. Redundancy, that's what I'm talking about. And they're not doing this the right way here. This is not the correct way to do it. But we're going to fix this up. Okay, so let's get these wires disconnected, the white and the yellow, and then I'll run them over onto these 2, and then we'll put it back together. Okay, so what I'm going to do is I'm going to show how I'm doing this step by step. This is why I make 2-hour long videos, because I want to show all the steps, and people want to see this. But for whatever reason, some people don't like seeing how to fix things. So let's remove this, and then we'll move it over there. Let's do that right. Let's do that right now. Let's cut half of this off. You don't need all of that. Let's feed it through. Let's do that after. Let's do this white wire first, because that is just going to be in my way. So let's do this wire first. Let's get this one out of here. Okay. There we go. Now we're free. Let's cut half of this off. Let's feed this through here. If it'll fit. It might not fit. Crush it down. We'll make it fit. Come on. The camera rolling and people are impatient. They want to see. Okay, come on. Let's cut off some more, because this is not cooperating. Let's cut this a little bit off. And let's strip back. There we go. Now we're cooking. All right. Let's Still need to flatten this some. Get this in. Why is this being so difficult? There we go. Let's cut off a little more. All right. There. That's what we needed. Solder this one. I always try and save that little 1/4 inch of wire length, but I guess there's no point. So let's solder this up. Okay. Got a good connection? Yeah, okay. Another thing I didn't notice right off the bat is these are quite corroded, so let's clean them off. Okay, let's cut this bit off. Let's cut this insulation back. All right. Pretty thick wire. Let's try and get it all in through the hole. There we go. Most of it got through. I'll clean this up after. The frayed ends is what causes shorts. We don't want that. I'll trim it after. Okay, so let's solder this. Lots of heat. Okay. I'll inspect those. All right. Yeah, see, I gotta trim this stuff off. All right. 2 good connections. Okay. So now we're back in business. We have 2 brand new buttons down there that are ready to start working. These 2 are burned out, and if you can see that. So we need to get rid of this cleaning stuff here. Let's get some cleaning stuff. Just going to use some cleaner just to clean out all the any oils or grease that's on the contacts, and just to give it a new lease on life. Okay, look at all the crap that was in there. If I clean this side, it just comes out black. And that's actually oxides. It's not dirt. But we don't need to clean that. Okay, let's clean this button. Clean the back. So we have to put the new button towards the new buttons here. Let me see if I got tweezers. drop that in. See, that's how it should work. When this part goes up and down, these two little red buttons, it should toggle that. And we're making contact now, so we're going to be good. Let's clean this one up. Clean this thing up. Yeah, don't ever spray deoxit or anything into a power switch because it will chew up the contacts. You can see how burnt up they are. They arc and then it just destroys themselves. So we got this good. Let's put this back in. Test that one. Okay. Now we need a little dab of grease. Smallest amount of grease on the back. This is where the slides. Let's just put a little dab like that. Like that. And then we can reassemble this part. Now we have to do this properly. So on is, that's off. Okay. That's off. This is on. So we want this to be like this. It's working. Okay. We need to crimp these. Crimp these. Bent them a little too far. Okay, this side. That sounds proper now. Before it wasn't even clicking. Okay, we are done. Perfect. Install that back in. You're gonna be careful. You flex this too much, these will snap off. And then there is a sleeve that goes over the whole thing to insulate it once it's back in the receiver. Okay, perfect. Okay, a bit of update time. So I finished the tone board and it's all back and reinstalled, and I put the screws back, everything's back to the way it was. Now that went well. It was quite a bit of work. I actually went through and replaced some of the tantalum caps as well. Even though I pulled them out and I tested them, they were all fine. I didn't want to take any chances because I did find those two bad ones on the Phono board. So they were good. All new caps, 5 new carbon comp resistors, or they're not new, but the carbon comps were replaced. So everything's done on the tone board. Switches were all disassembled and cleaned, and pots were treated. Now I'm working on the power supply board, and I'm finished with all of the retrofits. Got new resistors. I replaced probably about 10 carbon comps, all the capacitors, and right now I'm going to remove these two series pass transistors and make sure that they have make sure they're good, and then I'm going to re-goop the heatsink compound and put them back together. So that's next on my list. And I also have the relay removed. I tested the relay, and one side I had 2 to 3 ohms contact resistance. The other side I had 200 or 300 ohms contact resistance. So this is definitely, I think this is the problem I have with the right channel when I was doing my initial tests, this relay. So I'm going to polish these contacts, put it all back together, and put it back on the board, and then we're done. What's left is the FM tuner, AM tuner, and that Apparently the multiplex section is down here. You can't see it, it's all hidden. There's a multiplex chip here, and all the support circuitry. And they put the for whatever reason they put the multiplex circuit down on the tone board, and the tuners, and it has the IF, and that's all up here. Still need to hunt down why we have such a weak signal coming in for FM. We might have a dead transistor in here, which I'm hoping I don't, but we're going to get into that eventually. So the phono board's done, power board is done, with the exception of what I just mentioned, and then that just leaves the two power amplifiers I haven't touched yet. A lot of cleaning here, a lot of dirty, you know, it's got a film, quite a film of dust, so it's going to get a lot of cleaning, and we'll make this thing sparkle inside and out. Now, these two caps, these are 22,000 at 63 volts. I tested them. One measures about 17 and a half, and the other one's down around 15. So I'm going to replace these two. Trying to currently fight with my Visa card on DigiKey. It was declined. I don't know why. Some problem with online transactions. So I'm trying to get the capacitors in. These two capacitors are the same that's used in the amplifier that's going to be coming up soon on the channel. So I'm going to order all the capacitors now and have them ready. Okay, so I took a bit of time and I cleaned this relay 3 times, and let me see what it's looking at now. Put power to it, click it on, and I'm getting 400 milliohms on that side. Let's check the other side. 400 milliohms is not good enough. This side here I'm getting 20 ohms. See, this relay is not responding to cleaning. So I cleaned it 3 times already. I'm just going to give up on it. I think it's time for a new relay. These are Omron relays. And this replaces this. So that should work. Let's see if I got pins. The pins should match up. They do. They do. And so this is a, what is this called? Doesn't even say. Oh, it's a MY2. You can see it on top. It's cast into the plastic. This is an MY2N GS, 24 volt, Omron, original Omron relay. So we're going to install that instead and put an end to this. Alright, so I just finished recapping the AM/FM board here. Now, a lot of these caps, when I pull them out, they're fine, but they're going to get replaced anyways because they're nearly 50 years old. Now, I had somebody ask me, well, when you do a recap on a tuner, don't you have to do alignment after? And the answer is no, because they don't use electrolytics in any of the tuned portions of the circuits. They only use, for tuners, they only use electrolytics for power supply and audio coupling. That's the only 2 real reasons they use electrolytics. In the higher frequency parts of the tuner, where the RF and the IF, they have really small capacitors and they don't use electrolytics. So when you replace the capacitors in a tuner, you're really not changing anything that's tuned. The reason electrolytics usually last so long in tuners is because they're not exposed to high temperatures, they're not exposed to high ripple currents. They're just there to do some basic filtering and or signal coupling, and they have a really easy life. They sit and they do their job and they're not stressed. So that's why they usually outlast the capacitors in any other part of the circuits, like the power amplifier or power supply. So now that I got the FM, AM/FM portion done, the power supply board's done, the phono stage is done, I just need to reinstall it. Tone board's done, everything's done in here. I did find the cause of our poor tuner performance, and it happens to be, let's see here, a broken wire here on this coax. You can see, so once I reconnect that, I expect I'll get our tuner performance back. I don't know if I did that or if that was done before, but I suspect it was done before because of the way the tuner was so mute and deaf. For the lighting, you just remove 2 screws from the top here, and then this is free, this housing, and you just have to wiggle it out, and then you have full access to your bulbs once you remove this color filter. Be careful, this might be brittle, it might not. I'm going to replace all 8 of these lamps because some of them are burned out and some of them are on the way out. So I'm just going to put all brand new ones in. 100 hours from now, we're not going to have burned out lamps. So let me just do that. Alright, so the main power fuse in this was kind of silly. They had it up front here next to the lamp fuse, or the lighting fuse. So this is a 2 amp fuse for lamps only. And then they had the main power fuse here for the whole receiver. I don't understand why they felt the need to bring this fuse up front and put it right here. It was totally unnecessary. It's kind of unsafe too because look at how close it was to the secondary side of the equation. So shock hazard, electrocution hazard, didn't make any sense, so I took it out of there, abandoned it in place, removed the wires. I left the fuse clips there. You can use it as a spare fuse holder now. So on the back here we have a new fuse holder, and I opted to use an 1/4-inch fuse to 5mm fuse, so I'll put an 8 amp fuse in now. And this one also has a cover if I can find it. It's got a transparent cover that snaps over top. Alright, the part you've all been waiting for, or maybe not. This is probably the most uneventful part of the work I do. So these are the 2 power amplifiers, and they're quite dirty. You can see there's quite a layer of dirt on both of these. So my plan is just disassemble everything. I'm going to remove the heatsink, wash it. It's quasi-complimentary. It's got all original silicone on it. So nobody's ever done anything to these amplifiers before. It's all factory original. My plan is disassemble. I'm going to replace electrolytics, 4 electrolytics on each board. I'm going to replace all of these carbon comp resistors and repasting new goop for the transistors. I'll probably end up desoldering these 2 pins, removing this stabilizer, and getting it out of here so it doesn't get damaged. Alright, I think I'm done. Did a lot of work on these. Repasted transistor goop, new capacitors, new resistors all throughout here. Gave it a good clean, new potentiometers, trim pots. This thing's ready to go. Now I did notice there was some problems with the printed circuit board. The traces want to lift on these transistors. They're very tiny pads, and as soon as you put the iron to them, they want to lift. So I did have some lift dummies, but it's not a problem. You just fold the lead down and solder it. Transistors all tested fine. Usually they between 54 and 90. What is it? 96, 98. That's the range. The compound was pretty dried up on both of these and these, so this redoing it is a good thing. So I'm going to spend a little bit of time reassembling everything, and then we can get it back in the receiver. Alright, got everything assembled. Transistors are in, torqued down, repasted. Everything's good to go. Now, put these aside. I have something else that came this morning. This is new capacitors. Let's have a look. These should be the same size as the originals, and the only problem is they are snap fit. So these are negative or positive. The other 3, I'll cut them off. We don't need them, but we'll use this as our replacements. Alright, we're back together, and we're going to do initial power up. So plugging it in. Let's have a look. I don't know if you can read this. So let's give it a shot. And jumps up to about 80 watts. Relay click. And then it's climbing. It's climbing 90 watts, 91, 92, 93. Okay, so we probably have a biasing problem. So let's connect the meter and we will see what our bias looks like. Now, this is not conventional. This is a quasi-complementary amplifier, so we need to get this set up here. It says set volume control to minimum. Connect the plus lead of the DC millivolt meter to test point. Okay, where's test point? Test point is here with no connection to it. So let's connect one there. And let's connect the other one to the minus lead of the B2 power supply. So B2 is the negative power supply. And that should be our... Okay, can you see this? Let's turn this on. Let's get a screwdriver ready. Now, there's 3 pots here. One is overload, I believe. The one down here at the bottom is your DC balance, and this one is your offset, or the bias. So let's check this, and they want 30 millivolts. Let's see what we got. Oh, we got 50. Okay, let's turn it down. Okay, that's 30 there. Power consumption went down to 81 watts. I'll shut this off and then I'll get set up on the other channel. This is just quick and dirty. I'm just doing it quick and dirty because I don't want any overheating. So let's connect up to the other channel. Okay, screwdriver ready. Turning it on. I'm still at 57. So let's turn this one down. Bias was actually about twice what it should be. Okay, here's 32, 30. We're down to 66 watts. 67. Alright, I feel a little better about that now. I can let it sit without smoke coming out of it. We can check that right now. DC balance between ground and speaker output. There we go. Turning it on. Really click. Looks like we got 0. Oh, it's just a bad connection here. Okay, I'll adjust this. It's kind of drifting. Turn it to 0, but then it drifts, so I'll come back to that. Again, we're going to do the other channel, turning it on. Relay click. Now we got 100 and some. Quite a voltage there, but it settles. Let's turn it down. Okay, that's a rough adjustment for bias and DC balance. So I'll go through on the instructions. I'll do that off camera. I'll make sure it's all fine-tuned. I'll connect the load, do all that, and then we'll get on to testing. Alright, so let's do full power test here. We got it all wired in for, let's turn power on. And let's get this thing going here. I got 1000 hertz tone going in. Let's see, controls, balance. I have both channels driven, I do believe. Okay, let's set this up properly. Okay, let's take it up to clipping. I went through and did the DC balance and the DC bias for both channels and got them set up properly. Here we go. Okay, there's clipping. Let me get a little better visual on this. See if I can find right there. Okay, I need to adjust the amplitude a bit. Okay, right there's clipping. Let's back it off. Right about there, I think. Start our timer. Hope you can see this. Alright, we'll just sit and wait. We are at 34.27 volts RMS on the output. That's our power. I'm just going to turn the fan on for the heat that's coming out of this thing, and then I'll come back and I'll let you know how it works out. Okay, we're at the 5-minute mark. So I'm going to shut down the fan. I'm going to show you the heat sinks are actually not bad. They're sitting, this one's sitting right around 50 degrees Celsius. This one's less. This one's about 40. Let's see if we can get a peak on here somewhere. It's 41 or 42 degrees Celsius. So we're holding not too bad. Okay, we're at 9.5 minutes here. Let's check our last. We got 55 degrees on this side. We got here, what do we got here? Peaking at about 47 on this side, a little bit less. I'm going to turn this down. I think it did prove its point. It's working good. I'm going to let this settle for a bit and let it cool, and then we'll do some square wave tests. There we go. And what do we have here? 1000 hertz tone. We're only developing about 1 watt or 1.5 watts. Okay, so bass control and treble control are cut out right now. Let's cut in 200 hertz. Bass boost. Bass cut. Doesn't have much of an effect, especially the mid-range rotation here. It doesn't seem to have any effect. Let's go 400 hertz. And the effect is a little more dramatic. Okay. Treble control is not cut in. Let's do 5 kilohertz. No, let's do 2.5 kilohertz. Oh. Still a little scratchy. I have to work that pot some more. 5 kilohertz. Boost and cut. Okay. Low filter 15 hertz. 30 hertz. That's the rumble filters. High cut filter. Here's our high cut. Interesting. Balance control. Loudness. The switches are working. Everything's good. Okay. Let's muting. Okay. Let's increase the frequency here. Let's go 2, 3, 4, 5 kilohertz. 6, 7, 8, 9, 10 kilohertz. It's not too bad for 10 kilohertz on a quasi-complementary amplifier. That's actually pretty good. Let's go up some more. 15 kilohertz. 20 kilohertz. Slight difference between the two channels. You might have a slow transistor in there, or I don't know. Looks like there's a little bit of ringing on the tops and bottoms of the waveform too. You can see that squiggly line. That's not a problem, but let's see if we go up in frequency. Let's see. Let's go 25, 30. Seems to be getting a little more pronounced. It's having troubles with high frequency. Overall, it's not too bad. Where do we lose it? We lose it right around here. 16, 17 kilohertz. Lose our square wave. Alright. Let's do a little scan through the band here. Let's turn this on. Go to FM.
The Raven, Alberta Beach.
It's actually working pretty good. You're not getting much meter deflection. Getting all the stereo stations in well. Sounds good. That sounds clean.
What a change it feels, and like all of a sudden.
That one's not coming in.
They help to push one another. Nah, I think I'm gonna close down my laptop.
Those chairs, dining room, and bed.
It's got really good separation. Yeah, I don't know if it would benefit from a. I don't know if it would benefit from an alignment. It sounds pretty good, and it's picking up stations. The meter deflection is not quite there because I'm pumping in a really good signal from a rooftop antenna fed through an amplifier. So this thing should be pegging it at every station. It should be pegging the meter.
The TV network broadcasts
there's
diverse programs with sound, biblical teaching,
there's a good
music,
signal.
and inspiring messages from coast to coast, 24 hours a day.
Take your Valentine to Paris with love. February 13th.
This is the strongest station. It's coming up at about 6.5 on the signal meter. And that's it for stations, but it's actually working really well. I don't even think I need to adjust the dial accuracy. It looks like it was right on for every station. So I think I'm going to leave the tuner alone. I think it's working great. So yeah, let's just wrap this up and call her a day. Alright, here's a look at all the parts that went into this. Caps for the most part are pretty okay. These Elnas, these are probably the best caps that were ever used in vintage equipment, these Elnas. 50 years later, and I see a lot of these tests like they're brand new. Doesn't mean they're still good for use. Like there's some in here that are weak, like this one here for example would probably be pretty weak. It says 220 at 16. What does it say? It says 179, and it's got a 5.5 ohm ESR, so that's baked. But you know, you get the idea. These Elnas here, I don't really know too much about these ones. These are dark blue or dark purple. They seem to be holding up. I've seen some of these fail from leaking at the seal. Trim pots I changed. Main filter caps I changed. These are all carbon comp resistors. For the most part they're okay. like I said before, about 5 or 10% of these are out of tolerance. And, you know, but they get drifty when they get hot. You know, temperature changes, they get all drifty. So it's good to get rid of these. And, yeah. Fuse lamps, I replaced them all regardless if they worked or not. Tantalums, I found 2 dead ones. So I replaced a few more. And all the ones I replaced other than those 2 were all good. And a relay that would not clean up. It's got gold-plated contacts, but they're kind of pitted. And I'd have to take the sandpaper to it to get it to work. And I'd just replace it. And that's pretty much it. Well, there it is. It's all back together. It's working good. I'm going to enjoy listening to this one for the next few weeks. And we'll get this off the bench and something else on. What is today? Wednesday the 22nd, January 22nd. And hopefully I can get this video edited, rendered, and uploaded for Friday. So hopefully you'll see this Friday. But just want to mention, I'm going to do things a little different around the channel. I'm not going to be busting my ass for doing weekly videos anymore. It's just too much work. Especially when you get a repair that's really involved, or a difficult repair, or a repair that fights me to the end. It's really difficult to stay on a 1 week schedule. So I'm just going to do the repairs, and then every Friday when I have one ready, I'll post it. And then you might see some gaps in between. Well, you will see some gaps in between, because I am not going to bust my ass anymore. Because there's really no reward in it for me. And it's hard. I got other things to do with my time too. So, yeah, thanks for watching on this one. This is actually a fun one to do. I enjoyed working on this receiver. It's easy to work on, straightforward, no surprises. It was nice, and yeah, I enjoyed it. Hope you enjoyed it too, watching. Alright, so take care. We'll see you on the next one. Thanks for watching.